So in this lesson, we're going to discuss derivatives of constants and linear functions. So a constant is just a plain number. So a constant, for example, could be f of x is equal to 2. So it's just a number with no other variable attached to it. So the derivative of a constant is going to be 0. So that means the derivative of the function f of x equals 2 is going to be 0. So we can write f prime of x of 2 is 0. So like I said, the derivative of a constant, which is just a number, is always 0. So that means the derivative of the function 7 is also going to be 0. So now what about if we have a 2x instead of a 2? Well, if we have a coefficient out in front of a variable x, the derivative is just going to be that coefficient out in front. So if we have 2x, the derivative of that is just going to be 2 because 2 is the coefficient in front of x. So that means f prime of x for this function is going to be 2. So then if we have f of x is equal to 7x, that means the derivative of this is going to be 7 because the 7 is coefficient in front of x. So we're going to have f prime of x is going to be equal to 7. So now what about if we have a function that combines these two things? So the function below here, we have f of x is equal to 3x plus 5. So now we have a coefficient in front of x, and then we have a constant. So what we can do is we can use both these properties here to evaluate each term in this function separately. So we'll start with the 3x. So I'm going to find f prime of x, the derivative. So first we're going to take the derivative of 3 of x. Well, using the properties that we just discussed, the derivative of 3 of x is just going to be 3 because 3 is the coefficient in front of x. So we have 3 as the derivative of the first term. And then we have a plus 5. Well, we know the derivative of any constant is going to be 0. So that means we'd have plus a 0 here. So we're going to have f prime of x equal to 3.